In this video, we'll take a look at calculating a line integral for a two-dimensional vector field. Okay, so the vector field we're looking at is y comma minus x, and it's shown in this diagram here. So you can see that the vector field is sort of rotating in this direction around the origin, and the curve that we're integrating over is a half circle of radius 2 centered at the origin, starting at the point 2 comma 0 and ending at the point negative 2 comma 0. So it's shown here in purple. So starting at this point and going around in this direction and ending at this point here. And it's only a half circle because the parameter t only goes between 0 and pi, right? So 0 to pi. Okay, so to be able to set up this integral, right? So if you remember from before, a line integral can be calculated as an ordinary integral. So here t goes between 0 and pi, so between a and b. The vector field is pq, and then you take the dot product with r prime, and then you calculate the integral with respect to t. Okay, so we need to set up this integral, right? So we need to calculate r prime. So the derivative of x is, the derivative cosine is minus sine. So you have minus 2 sine t. And then the derivative of sine is cosine. So you have 2 cosine t. Okay, and then, so that's this part here. And then for the vector field, right, so for the variables y and x, I need to plug in the components of r of t, right? So 2 cosine t gets plugged into x, and then 2 sine t gets plugged into y. So the integral becomes from 0 to pi. So again, p is y, which is 2 sine t. And then q is minus x, which is 2 cosine t, so you get minus 2 cosine t. So here you don't want to confuse r with r prime, right? So the x and y here goes into p and q, and then the r prime is coming from here. So you have minus 2 sine t, 2 cosine t, dt. Okay, so first, before we integrate, we need to take the dot product of these two vectors, right? So 2 sine t times minus 2 sine t gives me minus 4 sine squared t, and then plus minus 2 cosine t times 2 cosine t, so that becomes a minus 4 cosine times cosine is cosine squared. Okay, so we can simplify this a little bit. I can factor out a minus 4. And then I'm left with sine squared plus cosine squared. But we know the Pythagorean identity, sine squared plus cosine squared is just equal to 1. So you get minus 4. The integral from 0 to pi of 1 dt. And then the antiderivative of 1 is just t. So you get minus 4 t evaluated from 0 to pi. So when you plug in pi, you get minus 4 pi. When you plug in 0, you get 0. So the value of the integral is just minus 4 pi. And if we want to calculate the decimal value, So minus 4 times pi. I got negative 12.57 approximately. Okay, so that's how we calculate the line integral of a vector field. So make sure your vector field is set up, your parameterization for the curve is set up, and then you can set up the integral exactly like this. Plug in x and y in for p and q so that everything is in terms of t. Calculate r prime, that goes here, and then you take the dot product, and then here it just becomes an ordinary integral that you can calculate. In the chance that this integral becomes very difficult to compute, then again it's just an ordinary integral, so you can use a numerical calculator to just calculate the integral. I have to be careful here, so it's sine squared minus 4 cosine squared dx. I mean dx dt, it doesn't matter, it's just a variable. And you can see that the value of the integral is exactly as we calculated it. Okay, so that's example 2.